Hey guys, today we're going to be learning about combinations. And we're going to start with a quick definition of what a combination is. So for our uses today, a combination is a collection of items or people or whatever we're talking about where order doesn't matter. Now, tomorrow's lesson, we're going to be doing permutations where the order does matter. So it's just important to understand the difference. So for our purposes today, when we are making different combinations of things, the order does not matter. So some examples of combinations are choosing members for a club or game. Doesn't matter which order you choose them in, it's just a collection of them. Or selecting crayons to color with. You can have a combination of colors, but the order doesn't matter. Okay, so to find the total number of combinations of n objects, and those are variable because we don't know how many. It's important that you use the letter n though, because it's going to correspond to our formula. Taken r at a time. So a certain number at a time, which we're calling r for our thing, for our formula, we use this formula. Okay, so the beginning of it is just saying taking a combination of items, n items, taken r at a time. You don't have to do any math with this. This is just how you write this part. You will take this number, and this is called a factorial, this exclamation point, over, divided by, n minus r factorial times r factorial. Okay, so I know this looks really weird. That's okay. It's brand new, but we are going to see how to do it, and it's really not that bad once you get the hang of it. Okay, so this is our formula for combinations, and now I'm going to take you through how to use it. Okay, so let's look at an example. So the basketball team has 10 players. Only 5 can play on the court at one time. And I don't follow sports, so I have no idea if this is a realistic scenario, but I'm going to assume so. So our question is, how many different groups of 5 players can be formed? Okay, so we're going to use our formula. We're going to put our C because this is a combination. It doesn't matter what order. And it says n objects taken r at a time. So our total number of objects goes here. We have 10 players. This is our n. And we're taking them 5 at a time. 5 at one time. So 10 players taken 5 at a time. Okay? Then we're going to plug it in. Our n is 10, so we're going to do 10 factorial And then we're doing n minus r, so 10 minus 5 factorial, and then r factorial, so 5 factorial, okay? So let's simplify this a little first. We've got 10 factorial, 10 minus 5 is 5 factorial, and 5 factorial. Now, what factorial means is it's a counting principle. It's how we find all these combinations. So we would write 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you're going from whatever number is in front of the factorial and you're multiplying by every number counting down to 1. So down here we have 5 times 4 times 3 times 2 times 1, and we do it again. 5 times 4 times 3 times 2 times 1. Okay? Now, before you go multiplying, see if you can cancel anything out. So 5 divided by 5 is 1, 4 divided by 4 is 1, 3, 2, 1. I got rid of all of those right off the bat. Okay? So now I just need to use my calculator to multiply 10 times 9 times 8 times 7 times 6, and I'll get 30,240. And on the bottom, I'll multiply 5 times 4 times 3 times 2 times 1, and I'll get 120. And then I can just divide top number divided by the bottom number, and I'll get 252 different combinations. Now remember, this is when order does not matter. So we might have some different orders of players going on in our combinations. Okay, tomorrow we'll get into the scenario where the order does matter, and that will change our numbers. Okay, so let's try some more. In this example, you just got a free ticket. You got a free ticket. And can bring along 2 friends. Unfortunately, you have 5 friends who want to come. So you're going to have to choose. Okay, so how many different groups of friends can you bring? Okay, so let's set up our formula. We know it's a combination because it doesn't matter what order you bring them in. You've got 5 total friends, so your bigger number, and you can take 2 at a time to the concert. Okay, remember this number goes on top with a factorial, and then 5 minus 2 with a factorial, and then 2 with a factorial. Okay, let's simplify that first. 5 factorial over 5 minus 2 is 3 factorial, 2 factorial. Okay, let's write it out. 5 times 4 times 3 times 2 times 1. 3 times 2 times 1. 2 times 1. So this is the 3 factorial, and this is the 2 factorial. I'm going to see what we can cancel. We can cancel 1 and 1. We can cancel 2 and 2. And we can get those 3's right there. Okay? So what I have left is 5 times 4, which is 1, which is, how did I miss that? Did I miss something? Oh, no. Okay. 5 times 4 is 20. And 2 times 1 is 2. 20 divided by 2 is 10. So you will have 10 different groups that you could bring. Sorry, in my notes I missed the 3. And so I had different numbers here, but it works out the same. All right, 10 different groups. All right, so let's try another one, get the hang of it. On this one, Emily is packing her bags. For vacation. Well, not for vacation, from vacation. She's coming home. She bought 6 gifts. With her friends back home, but only 3 will fit in her bag. I'm gonna have to mail some, buy another bag. All right, how many different groups of 3 gifts can she take? Okay, so again, we're assuming the order doesn't matter. We're going to have some groups that have the same 3 gifts but in different orders, but that doesn't matter in this scenario. So here's our combination. She has 6 total gifts, but she can take 3 at a time. Okay, so big number on top, 6 minus 3, and then 3. Okay, write it out. 6 times 5 times 4 times 3 times 2 times 1. Here we've got 6 minus 3 is 3. So 3 times 2 times 1. And then this guy, 3 times 2 times 1. Okay, cancel anything that's in common. So you're left with 6 times 5 times 4, which is 120. And 3 times 2 times 1, which is 6. When you divide them out, 120 divided by 6 is 20. So 20 different groups of 3. All right, so let's see, we've got one more that we'd like to do. You're going to try this one on your own. So you're choosing teammates. For a game. And are allowed to choose 4. You have 6 friends to choose from. How many different groups can you choose? Okay, so try pausing the video and try this on your own. Hopefully you've paused and you're back. Let's solve it together and check your work. So we're making a combination of 6 taken 4 at a time. Okay, 6 goes on top, then 6 minus 4, and then 4. I'll simplify that. That's 6 factorial. 6 minus 4 is 2 factorial, and 4 factorial. Let's write it out. 6 times 5 times 4 times 3 times 2 times 1. 2 times 1. And 4 times 3 times 2 times 1. Cancel what we can, the 4s, the 3s, the 2s, the 1s, and we have left 6 times 5, which is 30, and 2 times 1, which is 2. 30 divided by 2 is 15. So you can pick 15 different groups for your team. All right, hopefully that makes sense. Let me know if you have any questions, and have a great day.